As engineers, we are here to design things. These things can be anything from a building to a circuit. There's no way around it. The old adage that a picture is worth 1,000 words is still true today. It is much easier to express a complex idea as a picture than through a written description. Everyone agrees that drawing the picture is important. The problem is that people can't agree on how it should be drawn. Hand drawing is and always will be useful. It can be done quickly and collaboratively. The problem with hand drawing is that it generally lacks precision. I'm not saying that it must lack precision, but to make hand drawings precise, it takes a great deal of time. Hand drawing is good for a start, but it generally always pays to create an electronic drawing. The main reason is that electronic drawings can be easily edited, shared, and revised. The electronic drawing, however, is where we hit a snag. Every engineer has their own preferred software that they like to use to create drawings. They view all other software as inferior. It is generally a point of personal pride and contention. Be it MicroStation, SolidWorks, Google SketchUp, or any of the AutoCAD flavors, vanilla, mechanical, Civil 3D, they have their own preference. Here's the dirty secret. You can do all the same things in each of these programs. The main difference between them has to do with specialized tools that make certain tasks simplified. For example, SolidWorks is streamlined for developing 3D mechanical assemblies. AutoCAD Civil 3D has tools for handling contour drawings. I find the argument of what drafting software to use is boring and regressive. There is one great equalizer, that is paper. In order for anything you design to be built or created, you are generally going to need to print it out on a piece of paper. Paper is disappointingly two-dimensional. This means we need to simplify our 3D representations down to 2 dimensions. This is usually accomplished by assigning sides, a front, back, top, bottom, left, and right. With these basic drawings, there are 2 more views that are important. These are the section cut and the isometric view. A section cut does what it says. It cuts through the exterior and allows you to see inside of an object or building. An isometric view is a way of portraying 3D images in 2D. It does this by orienting to different angles. Now, I'm going to demonstrate the drawing process on an incredibly exciting tissue box. I just want to say as we get started here that I did not draw all these things this fast. I've taken it and I've double timed it so that things are moving a little faster, but it'll make for a little less boring video. Now, we're drawing a tissue box, so surprise, surprise, we're going to be drawing a lot of rectangles. I'm going to start again with the top, and we'll start with a rectangle just to represent the top. When you draw the top view, it's basically like you're looking down at the box. Here, I have some graph paper, so it can help me draw a straight line, but I'm also using a ruler. As I go through, you see me make these little tick marks. Those are construction lines. They basically give me a target when I'm drawing the curve to represent the opening of the box, which you've seen me mess up pretty badly here. But we're just going to keep going on to the bottom. The bottom is a little less interesting than the top because the bottom is just a simple, straightforward rectangle. We go from the bottom to the front, so from something boring to something more interesting. And guess what? Surprise here, we're going to go to the back after this, which will be another rectangle. But the front, we're going to start with the top and the 2 sides, the bottom. And what's important to realize here is when you're looking at the front, you have the opening, but behind the opening, you have the back edge of the box. So truthfully, when I drew that top line, I could have just drawn one straight line. Again, front to back, and the back is just going to be a rectangle. and the side. And I followed up side with typical because a box has two sides, but those two sides are exactly the same. So it's not worth spending your time drawing two separate sides because they both look exactly the same. Now what we're going to do is go back once I've drawn all the drawings and give everything some dimensions. So sketch them in. The little lip on the front edge is 2.5 inches, the side is 5 inches, the back lip is 4 inches, and the entire length of the box is 9 inches. Since these are hand drawings, I'm not being super specific at where I label the edges, just making sure that I get all the dimensions on there. And basically that's what you do if you were sitting in a group just drawing these things out by hand. And that's where hand drawing really shines. Not in its precision, but in its ease of coming up with something and expressing it to another person who's sitting right there. So the little lip at the bottom there is 1 inch, located in the middle, which is 4.5 inches. The back's just a rectangle that's 9 inches by 3.5 inches, and the side is just 3.5 inches by 5 inches. Once I've dimensioned that, we're going to go into some of the more special drawings. The first is going to be the section cut. And what I'm doing right now is drawing into cut lines, which basically tells you where the section cut is happening. So you label it on, let's say, the front or the top, and then you can go in and draw your section cut. And the section cut is what happens basically when you took the tissue box and cut it in half and looked directly at the side. So when you cut it and look directly at the side, you can see a rectangle, and we're basically looking right down the middle of the opening where you would take a tissue out. And when you look past that, you can see the edges, but when you make a section cut, it's always very important to denote what has been cut. So I'm taking a highlighter here and highlighting the edges of the box that have been cut. Until I did that, it was just a rectangle, but you couldn't really tell what I had cut. The final special drawing is an isometric drawing, which is a way to draw a three-dimensional thing in 2 dimensions, but it can appear to be 3 dimensions. And the way you do that is basically by skewing straight lines by 90 degrees. So what you see me doing here now is basically counting and marking so that I'm going to go through all those boxes at 45 degrees. So something that would have appeared at 90 degrees in the picture now appears at 45 degrees. So what we're seeing basically is I'm taking something that has right angles and I'm warping those angles so that I can show the 3rd dimension. You see everything basically lines up at a 45 degrees if you look at the grid on the screen that I'm writing. And you can say, even though this is a double time, it takes some time to draw these things by hand, because an isometric drawing is simple by hand. An isometric drawing is actually not very difficult when you start using computer software. And I'm going to draw some more construction lines to help make the cutout where you can pull the tissue out of the box. Here, for the first time, I have some lines that I get to erase, being that there is no line that you can see looking through the opening of the tissue box. So there you get a full tissue box. The only other thing I want to say here is that when you're doing the warping of the angles, the only thing that becomes difficult is circles, because now, since all the angles are warped, circles don't exist anymore, and all circles appear as ovals.